so welcome back, and this is March 15th, and this is today's daily LeetCode problem. So today it was another binary tree question, and it's honestly been the theme of the week where each problem so far, they've been giving binary tree questions, so this is great tree practice. So what we have here is we want to see if the given tree is complete. Now, a complete binary tree is when at every level, all of the nodes are full. And so that just means that there's no missing nodes at any of the levels going down. And then at the bottommost level, the nodes are being filled from left to right. Okay, so in this case, since the topmost levels are all full, there's no missing nodes. And then the bottommost levels, the nodes are filled from left to right. It's okay that there's one missing here as long as it's being filled from left to right. Make sense? And so secondly, if we look at this example, we know that this is not a complete binary tree because, well, although these first two levels are full, the bottommost level isn't being filled from left to right since we're actually missing a node right here. Okay, so I think that kind of defines most of the edge cases. Like, I think these two examples are enough to kind of get you going. So what we're going to do is provide a breadth first search solution for this, and we're going to do it iteratively, not recursively. And this is also called like level order traversal. And I think that's why I find this question fairly easy to get started. And it's just because the intuition behind how you solve it can come quite naturally. It may just be coming up with code that makes it a medium level question. And that's because you can kind of understand how, if you look at this, you might say, okay, I want to explore at each level, and I want to see, okay, is this level full, and does it kind of fill from left to right? Yes, it does. And then the next one, yes, it does. And then the final one, okay, no, it's not full, but is being filled from left to right, and there's no other level below it, right? And so that's where, you know, it's easy to whiteboard the question, but might be hard to come up with the code itself. So why don't we go ahead and get started. So this is once again the iterative solution for it. And so we're gonna have a queue since we're dealing with breadth first search, and we're gonna immediately put the root node inside of it. So while we have our queue, we're gonna continue iterating, and we'll say, okay, for underscore in range, the length of our queue. This is just standard templating for whenever you're writing a kind of iterative breadth first search solution. So if you ever want to see like a templated how to perform breadth first search iteratively, this is often like the standard code you would see. So this is where I'm pulling it from. And so next, what we're going to do is we'll say, okay, how do we know whether or not it's complete or not? And there's a very simple way you can actually do this. And once you see it, like it clicks very quickly. Okay, so what we can say is, okay, once you see the first kind of empty node here, there should be no other nodes that come after it, right? So in this case, since the first time when you're exploring these levels, we visit this node, then this node, this one, then this one, then this one. That's how we'll be kind of looking through the node. Once we see, okay, now that I've gone to this place and there's no node here, I shouldn't see any other nodes. And yes, that's correct. When we tried to continue iterating, there was nothing else. And so that's how we know it's a complete binary tree. But in this case, we see that, okay, we visit this node, this one, this one, this one, and this one, and then we see, okay, we found a null. Like we can say found null is equal to true. But then since we see a node that comes after it and we already found a null pointer, then we know, okay, this is not a complete binary tree. All right, so if that explanation doesn't make sense, maybe watch what I just said, or I think looking at the code, it can quickly make a lot more sense. So why don't we go ahead and implement that? So what we'll have is a variable called found null, just like we explained or described. So that will be initially set to false. So then we can say, okay, our node is equal to the queue. Oh, and I just realized we want to be using collections library and use the DQ and grab the root from it. And so then we just pop left and then we have that node. And so we say, okay, if that node doesn't exist, then we'll set our found null equal to true. And so from there, we want a next if statement. And so this is already saying, okay, this is how we handle actually setting, okay, we found that null. And then we want to say, okay, what if we found null? And so that means that, okay, since this queue is going from left to right, we haven't sorted that order yet, but we're going to. As we're going from left to right, left to right, left to right, when we still have something on our queue and it gets popped off, if the previous iteration or previous thing that was popped off was null, that will have been set to true. And so we know in the case where, okay, the previous node that we were looking at was null. And so since something else was on the queue here, we can return false immediately. So let's just quickly return false. And then finally, what we're going to do is we're just going to add to our queue from left to right. So we'll do, let's think here, queue.append node left, and same thing with the right node. And so the reason why we're not even checking, okay, if node.left and node.right exists is because we want to do it at this level here when we set our found null equals to true. And so other than that, we just want to return true if we're able to iterate through our entire tree or through our entire queue. All right. Oh, we got a false here when we shouldn't have been. Let's check that case. So here, if found null. Oh, here. We want to do an else if here. So yeah, because we don't want to set it in that case. Let's increment these. Let's go ahead and try that. Accepted. Yeah, so just what I did wrong there is, okay, we don't, if not node is found, then we set found null equal to true. But then since this case was coming right after it and we didn't have an else if, it would just immediately return false. So we were always kind of returning false whenever we found a null, which we don't want to do. So just splitting up this, okay, if not node, otherwise do this, and then finally else we'll do this logic. Okay, great, so let's try and submit that. And that's the daily problem. So I think, you know, that helped a lot. And initially I didn't understand that relation where, okay, we can kind of handle it generically where once you find your first null, if you find a node after that, or if there's another node in the queue that comes after it, then it's not a complete binary tree, right? So that's I think that's the real trick here. The way I solved it initially was I just kind of did a typical level order traversal, and then I just had these kind of if and else statements or Boolean variables, these flags I was using to check, okay, was the kind of previous level full or not? Or, okay, was the previous node null? And so I just handled, you know, these two independent edge cases, which kind of made it really confusing to read the code. I didn't realize that, okay, you can actually do it all generically. So yeah, so I hope it helped, and good luck with tomorrow's algorithm. Have a great day. Thanks.